All right. Today we want to explain the real meaning of the concept in mathematics called integration. Sometimes I will feel like teaching mathematics with Nigerian local languages so that we can understand better, because I feel that most of the times the problems we encounter or students encounter is the terminologies and their inability to understand the real life applications of the concepts in mathematics. So today I'll be showing us the real concepts and implication of the word integration. To do this, we'll be using a very simple function which says that if y equals 2x plus 1, let us find the integral of y respect to x for interval between 0 and 1. Now, to do this, we have plotted the graph. How did we get the graph? We know that 2x plus 1 can be written as 2 over 1x plus 1. That means that the slope or the that the slope of this graph of this line is 2 over 1, and the intercept on the y-axis is 1. So the line will start from here. We cut across here, and it's going to rise by 2 and run by 1 unit from point 1, and upon rising by 2 units, 1, 2. Then it's going to rise by 1 unit to the right. Run to the right 1 unit. So the line is going to pass through this point 1, 2, then this point 1. That's how we got this line. Now, the integral of any function is simply like to integrate means to bring together, to couple together. So integration is meant to bring together all points under a curve. That is the area subtended by any curve between one interval, between one point to the other, that is within a particular interval. The integral of y respect to x from interval 0 to 1 simply means to find the area under this curve this is a line actually, the area under this line between 0 and 1. Now this line runs this way. Between 0 and 1 means area from here to here, area that is the area bounded by this place. Take it up, so from here to here to here to here, that is the integral of that function. Is just another way of saying find the area of this shape, the area of this shape. Yes, because it's from x equal to 0 to x equal to 1. So that is how we got in this shape. It's actually a trapezium. Now, so we are literally asked to find the area of this trapezium. This trapezium can be redrawn this way. So let's draw it here. Yes, area of this trapezium. From 0 to 1 is 1 unit. Is 1 unit actually. Then from 1 up to 3 is from 0 to 3 is 3 units. That is 1, 2, 3. That means this height, this length is 3. And of course, this point here to here is just 1. It's just 1. So the integral of this line, of this function between interval 0 to 1 is as good as finding the area of this trapezium. Now the area of a trapezium is given as area A equal to half into bracket sum of the parallel sides. The parallel sides are this. This place is parallel to this side. So we are going to add them up. So into 1 plus 3 multiplied by the height, which is this place perpendicular to the parallel side, 1 again, multiplied by 1. This will give us 1 over 2. 1 plus 3 is 4 times 1. 1 cancels 4 here. That is 2 units. 2 units squared, or 2 square units. Just 2 units squared. So the answer is 2. Now, let's confirm this using the formula for finding integral. So let's integrate this with the conventional method of using formulas. Let's go. We are having the integral of y is actually 2x plus 1. 2x plus 1 respect to x. This must give us between 0 and 1. This must give us 2. Okay, before then, we can write this as integral of 2x plus 1x, 2x to the power 1 plus 1x to the power 0. If you don't get this, check out our previous videos. Respect to x. Now to integrate this will give us equal to 2x to the power 1, add 1 to it, and divide by the sum here, 1 plus 1. Now plus, we come here, 1x, 0, add 1 to it, divide by the product here, 0 plus 1. This will automatically give us 1 plus 1 is 2, that is 1 plus 1 is 2. So we have here 2x squared. 2x squared divided by 2 plus 0 plus 1 is 1. So we're having 0 plus 1 is 1. We're having x is to the power 1 divided by 1. So automatically, if 2 cancels this, we're left with just x squared plus x. So everything now becomes x squared plus x. So x squared plus x. So let's leave it this way. Now the interval is between 0 and 1. What that means is that we are going to be putting in 1. Okay, this will give us x squared plus 1 plus x at x equal to 1. That is the upper limit. Now minus x squared plus 1 at x equal to 0. We are going to be putting 1 in place of x here to have, instead of putting x, we now put 1. So 1 squared plus 1 in place of x here. Minus, we come here again. Oh, sorry. Minus, in this case now we don't use 1 again, we're going to be using 0. So minus 0 squared plus 0. So give us 1 squared is 1 plus 1 minus 0 squared is 0, 0 plus 0 remains 0. And if we add up, we have 1 plus 1 is 2. 2 minus 0 remains 2. The same 2 units that we got using our coordinate geometry is the same thing we have. So that is the graphical approach to integration and the algebraic approach. Whichever way you see it, you get the same answer. Sir Isaac Newton, who founded this, actually started from this place before we now discover the algebraic way of finding this. Now, if you want to know the real applications of these and more math concepts, you can join our Facebook page at High Score Online School or High Score Tutorials Online for more videos like this and for more insights. In that page, I shall be breaking down difficult mathematical concepts to the lay languages which we understand. In real sense of it, basic mathematics is not that complex. It's just meant for you to understand how these things work in real life. As we have just shown that the integral of any function is just the same as saying what is the area under that curve given a particular interval. All right, see you in the next videos. Thank you.